If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.
Hi. Hello, Lynzie.
Look at, we're in the same room. So this is our live from ANTEC 2024. The year it is. And we are in St. Louis together.
Missouri.
Yes. I had some barbecue. I did that's St. Louis.
There's St. Louis barbecue, yeah.
Okay, then I did the check the box.
Yeah.
So we are I'm Lynzie.
I'm Mercedes. And with our powers combined, we are PlastChicks.
And also
how did we miss it? Yeah.
It's fine. It's fine.
With our powers combined, we are PlastChicks, the voices of resin.
It's us. And we release a podcast the first Friday of every month
with a special guest.
Super special guest. So you can listen to it anywhere, not on Google Podcasts because that's going away as of April 2nd. I only
know that.
Yeah, I use it. So it's a little heartbreaking. But now I'm on Podbean. We'll see how that goes.
Okay.
But we have a super cool guest today. And we have dragged her up from the show floor, and she is super jazzed. We actually even prevented her from eating her lunch.
Her lunch is in the refrigerator over there. So
we're gonna make this snappy
and good.
Hungry, yeah.
But she's gonna do great.
Yes. So we have Ellen Lee, the technical leader of additive manufacturing research at Ford Motor Company.
Great meeting you, Ellen.
You too. Thanks for being here, and thanks for sitting in the center of us.
Thank you. We weren't trying to ignore you. We just don't know how to interview people in person, apparently.
Yeah, it's really coming down on us. So Ellen and I sit on the board of directors together, and so it is this
for
is
SPE.
For SPE sponsors this podcast. So this is your first ANTEC actually on the board, right?
Yes.
Or yes,
I was on the board last year, but
we weren't in Denver, right? Okay, I was like, I feel like so. First question before we even get to the meat of our conversation here, what are your thoughts on this ANTEC? How's it being in person and seeing all the talks live?
So the last ANTEC I was at was obviously before COVID, same as last year.
Mm-hmm.
And it's been great seeing talks live, the interaction with all of the attendees as well. It's great. And so far the talks I've been to have been really great.
I mean, honestly, I love nothing more than a talk while I can have a snack. And you can't do that, just any old time. If you're in person and there's snacks outside and there's a talk, I can do it. And
is it not easier to do virtually to snack while you're like
but I'm not buying the snacks. The snacks are on the house.
Oh, I love a free snack.
Free snack. That's the key part. All right. Well, I just wanted to know.
So, okay. Well, yeah. Moving on.
Moving on to the important stuff.
So, Ellen, can you share your journey in additive manufacturing, how you became?
Yeah. So my journey with additive manufacturing has been relatively short compared to some. I just started into additive about 10 years ago, but I've been at Ford working in the plastics industry for 25 years now. And so when I first started at Ford, I was working in areas developing in the research organization, developing novel materials for automotive use cases that were either higher performance or more sustainable. So I focused on things like polymer clay nanocomposites, as well as natural fiber reinforced composites, looking at bio-based resins and so forth. And one of the things, regardless of what the material development was, one of the big challenges that we always face was once you develop those materials and compound the materials, do some injection molding, and do your basic characterization, the stage of getting to test and validate the performance at component level and then the assembly level was always a challenge because we don't typically make or mold our parts. Our suppliers do that for us. And so either we need to break into production or we need to have a tool cut or something like that to really understand all of the influences of the processing and so forth for those parts. And so I had started hearing about additive manufacturing, even though, it's been around for decades. And I thought, wouldn't it be great if I could just 3D print this new material and into the geometry that I would need, and then test that. I didn't know much about additive.
In theory, wonderful.
And so then I started to dig in, and we had several, global printing facilities, doing all of our prototyping, doing that for over 30 years now. We have that capability. And I started to learn more and more about, what 3D printing is and what the capabilities are. And I quickly learned that my initial was not very well. But then I started to realize, there's a huge potential for additive manufacturing, not just for prototyping, but beyond prototyping, or even just like functional prototyping, where we could maybe start to create transfer functions for printed parts that then you could, relate to what a molded part and material would be like, and so forth. And the more I dug in, the more I realized there are a lot of technology gaps, especially in materials. And I like to think of myself as a materials girl.
Love it.
Madonna.
So I got really geeked out about it, and learned all that I could, started getting involved in some of the conferences, networking, and so forth. And so at that time, about a year and a half or so into my first idea, I started talking with folks with internally and externally, and put together a strategy and stood up our first kind of additive manufacturing research program. And in that time, started thinking about roadmaps and what the technical capabilities were at the time and where we should get to be able to realize some of these potential opportunities. So not long after, I was made a technical leader in that area. And
here we are.
Yeah, it's funny that you mentioned, it's so funny that you mentioned, the lack of materials knowledge in the world of additive manufacturing. I just had a flashback that I would like to share with you. I was at a trade show several years ago, and they had this 3D wing. And I saw this, I think it was probably some low durometer TPU. And I was like, oh, I went up to the salesperson. I said, what is this? What material is this? He said very proudly, it's our proprietary product. It's called resin.
Dear sir. Thank you.
I like to share,
what kind of resin? I
like to share something similar that I poured a lot of our product development. They're focused on the application. They're experts in. And sometimes when you go, there's an issue or you're looking at a product, and I'll always ask if it's a plastic or a composite, what material is this? And the joke is that it's SKP, some kind of plastic.
Oh, SKP.
I like that. I'm gonna use that.
Yeah.
It's gonna branch out now. That could have been what that GPU part was. That resin, that resin part could have been an SKP.
SKP.
I do love that you bring up the fact that your initial thought is oh, I'll just print it and it'll be fine in the injection molded process. That's an easy one-to-one, because I think that idea is kind of slowly starting to dissolve a little as we all learn a little bit more. But I know you're not the only person that thought that. I thought that so many times I've had this conversation. And people be like, yeah, you could just print it and then you could test it in injection molding. And it's oh, the differences.
So many.
I could get you a whole book on the differences. And to actually have to worry about that development between those two processes, that's a lot of next stepping.
People are always asking oh, this is made out of SKP. Made out of polypropylene. Can you print polypropylene? And yes, now you can.
Right.
Back then, there weren't polypropylene materials available for printing. But then, as we know, there's many different types of polypropylene, let alone the influence of the processing. And so it's like, yes, we can, but that's not going to solve your problem.
Right. I could just make this look cool. Like, that good? So, as we talked about, you've been super instrumental in developing Ford's strategy with the technical roadmaps for additive manufacturing. Looking forward, thinking how far you've come already, looking forward, what does that look like for the automotive sector in the next decade? Like, where's that go? I mean, besides a billion different options, but what's your opinion on that?
So we kind of went through this like Gardner hype cycle within Ford as well with additive. Like everyone was crazy about additive.
Right.
It's like huge. We got to do everything, and
It's like Hansel. It's so hot right now.
So hot.
so we started, doing quite a bit, and then realizing, oh, this is very hard, especially for automotive. So,
And what type of 3D printing or additive manufacturing were you doing?
Many different
Okay.
types. So I think where we are today, based on the big challenges. So the challenge
There we go.
Opportunity.
additive manufacturing for automotive is that we have extreme and we have very, very high volumes for if we want to make a big impact, and for most of our vehicles, especially the ones where we would want to utilize all the benefits. And we have very long, well, the lifetimes goes hand in hand with durability, but we have very low margins, right? Like we are very well known for beating up our suppliers for like.
As someone who has been on the supplier end of it, yes.
And so that combination makes it really tough. And so, within the additive manufacturing industry, when we talk about like all these, we often work across. So aerospace like us, they also have very high level of requirements and very long life cycles. Like they need durability.
Okay.
But, often price is not as much an issue to get that level of.
That's true. I could see that. I'm not buying my own airplane, but I sure as heck want it to last like I'm buying my own airplane.
Yeah, you don't want a plug to pop out of the
Or a door,
yeah.
for example.
So consumer goods, they have very high volumes as well. But a lot of times those things that you might be printing, they only need to live a year or less. And the consumers really desire personalization, which is like a big use case for additive. And then like when we compare to the medical industry, they have a huge need for personalization for certain aspects, right? And their volumes are low because of the personalization, and so they'll pay for those benefits. And so we're kind of in this like the toughest category.
You picked all the worst ones to go against. Got it.
So I think it turns out that it's a lot harder than we initially. We have had many wins, but we are a little bit at the mercy of what the technology readiness level is within the value chain. And so within 10 years, though, so far we have implemented a couple of production applications, and we continue to have those in very low volume. So we work very closely with our Ford Performance organization. So they do things like the F-150 Raptor. It's much lower volume than millions of trucks. And we do like certain performance packages for the Bronco, for example. And so there's a lot of kind of customization type things that we are capable of to pursue. So there are some fits that have a good business case now. But I think my dream is like to crack that big nut, get to scaled production where you can design for additive, get all the benefits, not immediate benefits for maybe that cost, but have these second and third order costs like David Tucker was talking about yesterday. But that said, we're also really benefiting from additive in not necessarily just parts on our vehicles, but in the manufacturing. So we get lots of business efficiencies through improving our manufacturability, our assembly line, and some of our components line, where we can make manufacturing aids and do lighter weight grippers or lift assists. So in some of these cases where we print things that go on end of arm tooling, for example, we can go to smaller robots, and then that helps save money and improves the kinematics, quality. So we're doing a lot of that right now today, but it's kind of transparent too.
Right.
Yeah, I wonder with the scalability, I'm surprised that I haven't seen that, obviously it's taken off a lot in over the past 10 years, right? But I'm kind of disappointed that I haven't seen designers really take advantage of the opportunities to design specifically for additive manufacturing, because there are structures that you can do in additive manufacturing that you can't do in any other process. And it's like,
not even injection molding.
Not even injection molding, right? And I wonder, do you think that as it continues to grow and maybe overtake some parts of other processes, do you think that we'll start to see that?
Yeah, so that's one of, I already told you I'm biased. Materials is like a big challenge, I think, in the industry. But one of the other big challenges is to understand design for additive manufacturing. And I think that there are a lot of designers in manufacturing that have been trained in conventional processes, and it gets kind of ingrained. But we're starting to see more and more training and education from the incoming workforce, like today's college graduates, even in high school. A lot of people are familiar with additive manufacturing and are starting to kind of really put that in their toolbox as well. Understanding how to design for that process. So I think it'll change slowly, but kind of retraining the engineers, the designers who have been using these other processes for so long will take some time to switch your mindset. But I think one of the big advantages is, potentially you could consolidate parts, right, to create those things that you can't print or you can't mold, for example. And a lot of times things are molded in several parts and then assembled because of those constraints. Right. So one of the challenges is then, often the way that we're set up, there's silos. So you might be able to combine the function of a single part by taking components from two different assemblies, but they fit together, right? But then
Now you're messing
with how the silos are set up, right? So I think there are some kind of infrastructural constraints as well that makes it a little. So yeah, it's a challenge.
So
many challenges.
I mean, opportunity. It's quite an opportunity.
And I, mentioned like younger kids, Gen Z, Gen Alpha, they're all starting to know what additive manufacturing is coming in. And my go-to gift for little kids is always the 3D printed pen.
Oh, right.
Because I'm like, let's get to talking about that. And I think it's funny because, even back when I was in school 15 years ago, we were talking about how there were a lot of engineers out there that didn't know how to design for injection molding. And now it feels like the flip is already quickly moving from okay, there were the people that don't know how to design for injection molding. Now it's you also got to learn this new thing. I know 15 years is kind of a long time, but still, the fact that now the people I graduated with, we're going to be the grumpy people being we know how to design for injection molding. I don't need to design for additive manufacturing. Injection molding, no. And it's funny to see that flip happen. Feels very quickly, but it's true. I guarantee nobody's talking about that at schools yet. Maybe talking about it casually, but not, there's no modules. I would be very impressed if schools teaching that. If someone's teaching that, let us know.
Colleges.
They are. Okay, well that's not a game.
But it's tough because when people talk about 3D printing or additive manufacturing, they talk about it like it's one thing. And the different additive processes are quite different from one another. So,
true,
you know,
yeah.
obviously there's different aspects of injection molding that have different design rules
Right.
that you could work around, but they have a lot of similarities.
Right.
In additive, there are some that are very different.
Right.
So the design for each of the additive processes is going to be quite different.
So teach the module and then the subset and the subset and the subset.
And for the materials design too. I mean, oh my gosh, I have a filament fed at home, and then I have an LCD, just like a little Mars Elegoo. You know, I never thought about that, about the actual material design behind the raw materials. Just completely different.
See your materials?
Yeah,
Oh man, I feel left out.
Oh, you're a material. You have your first 3D printer, didn't you?
Did I just haven't put it together.
Yeah.
So, you know, collaboration is kind of a key theme in your work, especially if you're trying to steal parts from other silos to get stuff done. So you've partnered with suppliers and universities. How do these collaborations kind of contribute to Ford's additive manufacturing strategy? Like,
Yeah,
where does that go?
That's a great question. So we depend on collaborating with the value chain because most OEMs, automotive OEMs, we're assemblers, right? So we're not making those parts. And so if we want to embrace additive manufacturing for specific types of applications, we need to have close relationships with that chain. And so I think one is kind of developing the supply chain to understand and to understand what there's incentives for in the supply base, right? So, you know, both the technical side and the business side of what the state of the supply industry is in additive really helps us to understand what kind we expect to develop those roadmaps towards using additive for different opportunities. So, but it's been interesting in additive because the additive industry and the automotive industry have not been, you know, they're not overlapping Venn diagrams, except for in prototyping for many, many years. Right? And so, you know, the question had been early on, like, do we take our automotive supply base and teach them, or do we take the additive supply base?
That's what I was wondering.
Teach them automotive. And it's
both are hard to
both are really hard.
Because I know as a former automotive supplier, it's a hard like set of standards you have to adhere to. What do you do?
The automotive supply base does things a certain way,
right?
And so if you want to get into it, we expect you to do some things.
Right.
And if you're new, you're like, oh, really?
Yeah. Right. And I would imagine from a supplier standpoint, it's hard. I don't know if it's difficult for you guys to get their attention specifically with additive manufacturing. I know, you know, on the master batch side, it's just there aren't a lot of companies that focus on it because it just feels like such a smaller market than the other forms of molding. But how has it been? How's it been working with your suppliers? Right. Which direction did you go? A little bit of both?
Yeah, we're doing a little bit of both. So like the interesting thing is there's a big, you know, value chain in additive to support like prototype parts. Like there are service bureaus everywhere that have several different types of additive manufacturing and they make parts. But normally they only need to make one of each kind of part ever.
Right.
So the interesting part, it has been like, how do you know what the performance of that part is? Or like if you had to make a second of those parts or a millionth of that part, is it going to be the same? Like they don't have any statistics. I mean, now some of them are starting to, but like in the very early days, like none of them knew how repeatable their process was, or the material was, or the, we
It's like the Wild West.
Yeah, so it's been interesting. Like one time, one of these supply service bureaus said, like, oh, we have great like uptime. Like this printer is like up 60% of the time. 60%. You got to get to like 99%.
You're like, that's nothing.
Yeah, I don't know. I have questions about like, there's a way to go to become. So it's been really interesting. But on the other hand, this design for additive really challenging, and there's for people to like change their mindset. So kind of teaching the automotive supply base all of that.
Which some of them are the ones that did not want to design for injection molding, I can tell you that. I mean, there's some long established suppliers that are probably very, content with the way they run their business and supply to the automotive industry. And I'm sure some of them are starting to see the writing on the wall and see that, additive would be a good play to, keep in their playbook. But very interesting to see some of those companies incorporating additive manufacturing for that purpose.
So, Ellen, you are on the board of directors for SPE, as with Lynzie, and you're also on the board for additive manufacturing and 3D printing. So how do these roles influence your work at Ford and your perspective on the industry?
I think it's really good to see the overall perspective of what's going on in the industry, where what technologies are being developed, both in plastics in general, as well as in the additive industry for polymer additive, to kind of gauge what's important, what the technologies are, and then pull in the ones that make sense for us to add them to our technical maps. And again, like I said previously, it helps us determine what the timing should be, what we should expect to be able to utilize some technologies. But we also, it allows me to engage more closely with different members of those organizations, like SPE in general, as well as the additive membership, to understand what they're looking for, as from the customer point of view, the downstream customer for vehicles. What do they want from their vehicles? So it's a good perspective. Cars are something that everybody knows about. Everyone has, at least, if not owning a vehicle or driving a vehicle, has been in a vehicle and has opinions one way or another.
Always got opinions.
And it's an easy topic to talk about.
Right.
Did you utilize 3D natives before their relationship with SPE?
I was aware of them. They have a good online presence to look for, what's new in additive. There's resources there. They're very good. There are a couple of those types of formats or forums or companies that have that kind of thing. I did use a lot of them just to search for information. Right. It's great. Their focus had been, previous to being part of SPE, was more in Europe. So it allowed us to probe more of what's going on in Europe, and then some of these other online forums, focus more on what's going on.
How is that comparison, like Europe versus US? I know, like, sometimes it's like, oh, it's trendy in Europe, so coming here.
Is it like recycling? They're so much better than I don't get that.
Is it no different? Is it staged like that, or is it kind of the world learning together? Just curiosity.
Early on, there was a little bit of that. Europe seemed to have a lot of the metal additive, a lot of polymer additive based in America, suppliers like Stratus.
Okay. Yeah.
And then, and Asia was kind of in very early days, very, very few companies and know-how. And the Asia market has like exploded very quickly, accelerated in developing good machines and technologies. And they, like, one of the big challenges that we have is figuring out the business case, right? And a lot of the big drivers for what the business case is how expensive materials are. Part of that is economies of scale, right? But part of it is there's only a certain number of suppliers for those types of things. And a lot of those suppliers are the equipment OEM who, had this razor and blade model or printer.
Yeah, it was that. I remember when I was like, oh gosh, this is dark. I used to manage a printing company. I was like, oh, I hate this model. I hate it.
But once they, a lot of the Asian machine manufacturers, they tended to be had machines and systems, so they've grown quite a bit. So there are some regional differences, but now a little less so between.
Okay, so they're not getting the cool stuff first, necessarily. I don't know, I just get jealous.
So, Ellen, what advice would you give to young professionals looking to pursue a career in additive manufacturing and research?
Well,
Besides, be a materials girl. I think that's always advice we give out.
Well, I think it first take a little bit of soul searching. What do you really love to do? And if it turns out it's materials, it's printing, figure out exactly what aspect of that, and then start attending, networking sessions or these go to conferences. But don't be afraid to reach out to somebody, either through networking or LinkedIn or something like that, and ask for exactly what you want.
I think that's so smart because I think it took me a long time to start
Me too.
asking people. And then once you do, you start realizing like people are like, yeah, I can help you. Like, absolutely, I'll do
People
it.
want to help.
Yeah.
People want to make.
You've gotten so bold with it now. You just tell them. You're like, you need to help me with this. Come here. You need to do this. You need to sponsor this for me.
I think
You need
that's
to teach
time
me.
to be part. I ask the people I don't necessarily know, but if I know you, we're past the polite asking. it's the here's my demand, 48 hours. But yeah, like I think that's really good advice because I know coming into this industry, like I didn't want to ask anyone or anything, and John Meckley, who just had the recently endowed scholarship, like he used to. I remember he told me he wanted to get me an internship, and he's like, "Well, I'll just call this guy and ask." And he's like, "Yes, I will do that, Lynzie. We do this." It was just, yeah. I think it seems so obvious to us, and I would argue not obvious to students coming into the industry.
But getting over the fear. I mean, I think we still go through it, right? I mean, like you obviously you serve with Ellen on the board, and when we talked about getting you for this episode.
Great example.
Yeah,
I was very because I find your whole, you are the coolest person I have been affiliated with, and I didn't want to ask you for an interview. Also true, but I didn't know if you'd want to do an episode, and so I, asked someone else, and then just told, just go ask her. And
yeah, she asked who to ask you. I think, yeah.
Well, or Sue said I should ask you, and then as soon as I asked you, you were like yes, and it's like, why didn't I just ask her?
I think, getting over your fear of asking people for help or asking questions, even if you think it's a dumb question, more often than not, other people had the same question and we're afraid to ask, right? They're just happy that somebody asked it. So, and no one's going to be like, that's a stupid question.
Right. Not to your face anyway.
Really not to your face.
Not to your face, and that's all you need. If you can ride high off of that, that's fine.
And generally, people.
You're absolutely right.
So making those connections.
And so, kind of summarizing this, we're you've talked about what you are doing at Ford and what you see as the future in like the automotive sector. But are there any like emerging trends or technologies in additive manufacturing? Maybe not necessarily something you can do, but you're like, man, if I could pull that in, that would be sweet. That you have your eye on or just think are cool coming up?
Oh, so many things. So one of the things that, well, let me back up a little bit. So a lot of people, when they think of additive, think of filament printing, material extrusion.
Right.
It's kind of the easiest to kind of grasp onto.
Right. Especially if you already work in plastics.
Right. Yeah. Extrusion, lays down. Good.
It's the closest in terms of like the materials
Yeah.
that you're able to extrude or make, create with. But it does have several limitations. One is, and I think everyone is familiar with, this layering creates weakness process. You don't get really good adhesion across. And, you know, in conventional polymer processing, even just weld lines, which are stronger than interlayer lines.
A little more squishy.
So often we are just designing those material extrusion parts to the lowest properties, like of, you know, whatever the Z strength is across those lines. And so the properties are very inelastic. Right? Like you can get really great, especially when we talk about composite materials, fiber reinforced materials, you can get like really good performance along that direction, but not across the direction. You're just looking at resin properties.
Yeah, heck of a wall.
So why not, instead of like dealing with the weakness, exploit the weakness or the anisotropy and align your load path with the print or the tool path, right? You can align the fibers in the direction where the load needs it, right? But for that, you would need to have out of plane printing capability. You're not just printing layer by layer.
Right.
You can like follow a contour or reinforce, you know, across something like with ribs. So being able to have that capability to plan out what your tool path is to do that would be excellent. Right? But that, like, it sounds hard, but it turns out it's even harder than you think.
Really?
Because when you design the part, you can like design the geometry, and then like typically you can even do design for additive, and then you slice the parts. But now if you're talking about like printing out of plane, having motion that's out of plane, you're not slicing, right? Like, and if you open up all the degrees of freedom,
Right.
you don't even have shells.
Yeah.
Like, it's not just that you don't have planar slices, you don't have shells, you can do whatever you want, right? So like go this way here, and then you could go across here, and you could skip a layer. You know, you're printing where you need to have the.
I mean, it sounds like it should be pretty possible, just, but like thinking about the code for it just makes me
Right.
nauseous.
It's a hard no for me.
It's like you need to be able to optimize what that geometry is, as well as what that tool path is.
It's like you almost have to incorporate like an ANSYS type software into what you're designing already.
Yeah. I mean, it feels like you could use AI to make it easier.
You know what? Let's just solve it.
AI. We should just ask.
Just add AI into our conversation.
We should just.
There we go. Done. We solved your problem. You're welcome. So, okay. Well, we can't do that. But that does sound that would be really cool to see stuff, you know, kind of build on like the existing technology and be like, here's this thing, and now here's this thing and it's strong, or here's this thing and it's strong and it's functional. Like,
I mean, it's kind of blowing my mind because that's really like, we're talking about designing for additive manufacturing, but this is like taking it to a whole new level when you're actually designing,
Yeah, a lot of times, and you use this kind of concept or workflow for conventional manufacturing as well. But typically you can do like a topology optimization for a part where you put in your constraints, where the load are, where the attachment points are, et cetera. And you'll go through this optimization where it'll tell you where you need material to have a functioning part. And a lot of the time if it's for injection molding, then you go in and you apply the constraints for unmolding and the draft angles and things like that, and it'll modify that design. You can do the same thing for additive manufacturing, castings, all these things. But that often will assume isotropic properties, right? They're just saying you need material here and here, right? And then, but then like for injection molding, there's a lot more you need to do to kind of tweak and optimize based on like if you're fiber reinforced, you want to make sure that fibers are in the right areas and right orientation, et cetera, especially if you're looking at like long fiber materials. So you can do the same thing for additive, but now you are removing some of the constraints. So, oh, but I could print this way or that way. So you almost need to have an iterative, like here's how I'm designing, but here's how I can move to like have a continuous print path and kind of go back and forth. So you need to do those steps at the same time. Very quick iteration.
Or you need
AI
to do it at the same time. Well, that's awesome. Well, I think we are just about out of time. And so we wildly appreciate you being here. And I'm going to thank myself for giving me the courage to ask you.
Lynzie, thank you.
And we love hearing about all this stuff. And thank you so much for being here.
And thank you for doing what you're doing.
Yes, so cool.
I do have one message for plastics.
Let's do it.
Like a lot of times you have you hear hesitancy from those injection molders or their jerks. Other people in the supply chain, because they're like, oh, additive. Why would I want to do that? And that's one of the misconceptions. It's just another tool. So, some things are best made by stamping. Some are best made by thermoforming. Some injection molding. It depends on what you need from that part. So one of my good friends in additive has said, when you get a hammer, don't throw out your screwdriver. So it's just something else that's in your toolbox. So don't be afraid to embrace additive. And people are starting to look at hybrid technology. So, I don't want that misconception to the SPE audience that it's taking away from any other,
Not taking away, it's only adding.
It's adding.
It's adding.
It's not good.
That's perfect. Perfect word in. Well, Dr. Ellen Lee, thank you so much for coming on the podcast today and for taking time out of your very busy schedule at ANTEC to come up to the 20th floor with us. That's right.
So much fun. So thank you so much for having me.